Hello. Today, let's take a look at interest, and we're going to take a look at simple interest and then compounded interest and then continuously compounded interest. Let's go. Okay, so simple interest is the situation where, say, you put $100 in a bank and you're offered a 5% annual interest rate. So that means that once a year, your $100 is multiplied by 5%, 5 over 100, or as a decimal, 0.05, which gives us $5, and that is added to your initial principal, which means at the end of your first year, you will have $105 in the bank, and then that will repeat. So to calculate that first year of interest, it would look like this. Your principal times 1 plus your rate. Because if you distribute that principal through, principal times 1 gives you your initial principal. Principal times rate gives you the additional amount added, and when you add those two together. Now, if you want to figure out what happens over time, you're going to repeat that process over and over. And the way you can do that in a formula is to raise your 1 plus rate of change to the number of times you're going to repeat this. And so that's our formula for simple interest. Now, compound interest is the situation where you're offered an interest rate, but that interest rate gets calculated multiple times a year. So here's how the formula adjusts to show that situation. You have your principal amount, and you're going to multiply it times 1 plus the rate divided by the number of times per year you compound it. Because instead of doing 5% twice, which would be quite a lot, you're doing your 5% divided into n times a year that you're compounding it. But now, by the same token, our time that we raised it to, which was in years, we now need to multiply that times the number of times we're compounding it in order to have the right number of exponential raises. So in this case, what compounding it semi-annually would look like in a single year would be our principal amount 100 times 1 plus 0.05 over 2 raised to the 2 times 1. And if we put that in our calculator, we have 100 times 1 plus 0.05 over 2 raised to the 2. That gets us $105 and around 6 cents. So the more frequently your interest rate is compounded, the more money you'll earn each year. Now let's take a look at another situation. Let's say that we're offered that 5% monthly. All right, so what's our N going to be in this case? That's right, it's going to be 12 because monthly means we compound it 12 times a year. So let's put those numbers into our calculator. So that's 100 times 1 plus 0.05 over 12 raised to the 12. And again, we can see that gave us even a little more money in a first year, $105.12. There is another situation, which is that your interest rate is continuously compounding. That means instead of breaking it down into months or days or hours or seconds, it is just continuously compounding. To calculate this, we use the following formula. So this is the Pert formula. Amount final equals your principal amount times E raised to the rate times time. E is a constant. It's an irrational number, just like pi. It's a number that occurs in nature. Technically, it is the limit as x approaches infinity of 1 plus 1 over x raised to the x. You don't need to understand that. What you need to know is that its value is approximately 2.718, and it can be found on your calculator right here above your division symbol, and you access it with the second blue key. And if you need to raise it to a power, you can also find it over here on top of your natural log key. By the way, the natural log is log base E, But we're going to get to all of that later. Right now, we're going to go ahead and take a look at this formula. So if I am continuously compounding my $100 for that same first year, that would look like this. My amount final will equal my $100 times e raised to the 0.05 times 1. And when I put that in my calculator, that's 100 times e raised to the 0.05. I get $105 and about 13 cents. So continuously compounded is going to be your best interest rate, but that should give you a good start on the difference between simple interest, compounded interest, and continuously compounding interest. Stay tuned for more information about E. We'll get into logarithms and natural logarithms. Consider subscribing to my channel so that you know when I put out a new video. And as always, keep on mathing.